In our previous videos I covered general TenGun concepts and how to display analysis results using TenGun's time series mode. In this video I will introduce assembly mode, where you can import existing 3D models, create and edit your own 3D models, and export 3D models in various formats including as particle data. First, let's load an existing CAD file. You can import a number of common file formats including IGES and STL, and our preferred step format. To enable assembly mode, simply select a view type of assembly at the bottom of the File Options dialog. There is one other important option here: append to current scene. When selected, the file is merged into the current scene, thus allowing you to assemble the complete unit using parts from multiple files. I won't use that option this time, but please keep this in mind, especially when loading CAD files. Once loaded, use the same controls to examine the model that you use for time series data. For example, use the mouse to rotate, pan, or spin. In assembly mode you can use the view menu to toggle between solid model view and a wireframe view. Handy keyboard shortcuts are VS to view solid, VW to view wireframe, and plus and minus to zoom in and zoom out. Finally, use the camera menu or the equivalent keyboard shortcuts to move the viewpoint around the model. For example, press Ctrl L to quickly jump to the left side, Ctrl R to view the right side, and so on. To save the model, select the Save Assembly as option on the File menu, and enter the new file name. The file format is determined by the extension, so if you specify a type different from the original, the data will be converted to a format for use with another application. Now let's create our own model. I don't need the exhaust manifold model anymore, so I'll delete that tab. And next I will insert an empty assembly scene. You can do this from the File menu's New Assembly option or by using the Ctrl and keyboard shortcut. Now we have a blank scene, so let's insert an object from the Object menu's Insert Object option. TenGun allows you to create a wide variety of basic 3D shapes, and you can combine basic shapes to create even more complex objects. Let's look at a box. The next dialog allows you to configure the geometry for the specific type of object. Notice that the default dimensions of each object are 100 units, and for an SPH application the units will typically be millimeters. Also note that objects are centered, so you will probably need to move something later if you are working with multiple objects. Now let's create a real model using multiple parts. For example, let's say I want to analyze the stress and strain and the temperature when I inject some hot metal particles into a container. For this I will use a closed box for the container, a pipe to hold the material that we want to inject, and a disc to push the particles in. I will also need to cut a hole in the closed box for the particles to flow through. So here we go, starting with a fresh scene. First, insert a box with no open faces. Now let's insert a solid pipe to use as a cutting tool. There are several ways to cut a hole, but this way is quite easy. I'll set the inner radius to 0 to create a solid pipe rather than an ordinary pipe with walls. The box width is 100, so I'll set the pipe outer radius to 40 so it fits within the side of the box. Remember to jot down the dimensions because we'll need them later. I use the default pipe length, so the pipe is completely inside the box. So I need to do two things. First, press the N key to cycle through the objects until the pipe is the active object. You can also select an object by right-clicking on it, but the pipe is obscured here, so I'll use the keyboard instead. Next I press Ctrl G to invoke the geometry editor on the active object. Use the geometry editor whenever you need to center, scale, rotate, or translate an object. Here I'll just move the pipe 50 mm in the +Z direction so it sticks out of the box and is not embedded in the far wall. Next, with the pipe already selected, press Shift right-click to also select the box. Then, from the Tools menu select the Difference option. This will cut the solid pipe out of the box, discard the pipe, and leave us with a box with a hole in one side. I always recommend saving your work as you go, so now we'll save this file. Now let's add a container pipe. The box has a capacity of roughly 1 liter, so I'll make a 220 mm long pipe with an inner diameter of 76 mm, which also has a capacity of roughly 1 liter. For this demo, this is close enough to what we really need. Now we need to move the pipe in the +Z direction so it aligns with the outside of the box. One way to align the pipe is to move it using the geometry editor. However, that requires you to calculate a lot of numbers. A much simpler way is to use the Join Faces feature. First, rotate the model with the mouse so we can see the far end of the pipe. Then enable Pick Faces mode by typing PF, and click the end of the pipe. Now rotate the model back to the front side, and with the Shift key pressed so you can pick an additional face, click the front face of the box. Finally, press the J key, and, voila, the pipe and the box will be perfectly aligned at the selected faces. Please note that you still have two separate objects, so the name join is a bit of a misnomer. If you now want to fuse these parts into a single object, you can apply the Boolean union feature. This join was a straightforward case, but it can also handle more complex cases where the object being joined needs to be rotated. Now let's add a circular plate that will be used to push particles from the pipe into the box. The plate is initially located in the center of the model, but we can use the Pick Faces and Join trick to align it with the end of the pipe. With the plate inside the hollow box and the long pipe, it is a bit difficult to see the edges of things we want to access, so you may need to rotate things until you can clearly identify the target faces. There we go. Now let's save this much in another file. The next thing we want to do is to fill the pipe with particles representing the liquid metal. To do this, we will use the File Export, Model as Point Cloud feature. Since we don't want to fill the box too, we will first delete the box, and later we'll undo the deletion. So here we go. We'll use the default point size of 1. And now, For creating the liquid metal particle, we'll use the Create Interior Points option. Now I will undo the earlier delete to get the box back. Then, since the point cloud for the metal was written to a file, let's load it back into the pipe. So here is our complete model with 4 components: the box, the pipe, the push plate, and the liquid metal particles. Now that we've prepared the model data, we want to convert the whole thing to particle format that can be run through our analysis application. To do this, we will use the File Export, Analysis Data feature. When we do this, TenGun prompts for an export template. An export template is an XML file containing information so TenGun knows how to create data for your particular analysis application. We have several standard export templates, and creation of custom templates is discussed separately. Notice in the console window that a number of warning messages just appeared. This is because this particular template is expecting me to identify some additional properties such as the type of material for each part. However, I skipped those details in order to keep this demo short, and we'll just use the default values. Now let's take a look at the export analysis data output by loading the file we just created into the text editor. This particular data contains a few header lines, the particle data, and a few trailer lines. This particle data contains a particle ID, material type, coordinates, velocity, and boundary condition type. Again, via the export template, you can create input files suitable for your own analysis application. This concludes the introduction to assembly mode video.